1/2 tool motorized backplate from Mark 46. I'll show you in this video next. Okay, so before we get into the coding, let's talk about the wiring diagram for the Arduino Nano for the backplate. I know it was kind of hard to see the wires on the actual backplate itself, so I thought I'd throw a quick diagram together to kind of explain how I wired everything up. Obviously, these battery packs will be for batteries, but they only had the 2 for the diagram, but just pretend these are 4. So you can see we have all 4 servos. I recommend when you get into the coding to kind of designate which of these servos you want to name. So like I named this one left 1, left 2, right 1, right 2. You'll see why you want to know like which position the servo should start and end at when you're changing the switch. So basic kind of configuration, like I was telling you, I'm powering the servos separate from the actual Arduino itself. So I've got these 2 servos, so positive, negative combined going to this battery pack over here, and positive and negative combined going to this battery pack over here. Now remember when I said that if you're powering these servos separate from the Arduino power, you want to make sure that the ground on both of these battery packs go to the ground on the Arduino. Otherwise it will not work. I don't remember the reasoning why behind this, but it just won't work, trust me. The other thing, I threw this in here. These are the LED strips that I was talking about. These are optional if you want to do them. Great, if not. You can power these off the Arduino. They don't draw that much power. So basically just wire up all of the grounds together and all the positives together and put them on the 5V and the ground on the ground. If you notice that the Arduino has 2 ground ports, you can wire everything to the same ground. It doesn't matter. It was easier to do these ground on this side and this ground on this side just to keep it kind of like less messy. Make sure you wire the positive value to the 5V. There's also a VIN, which is an unregulated power source. You don't want to wire that because it will blow these lights and they won't work. So make sure you do the 5V. Now for the data point, this is where I was saying if you want them to all be the same color and do the same effect and all that stuff, you can just wire all these data import or these data pins together and then wire them to, I have them on pin 6, D6. You can put them on any of the pins here, the data pins, it doesn't really matter. Now, if you wanted to say make each one of these uniquely different, you would have to wire each one of these data pins to a data pin on Arduino. But since I want them all to do the same thing, I just wire them together and they're on data pin 6. The other call here is the data pins for the servos. Now you want these all to be separate. Now I have them on 12 through 9, where it's kind of hard to see in the graph, but 9 is over here, so that would be left 1, and then the left 2 would be 10, and then right 1 would go to D12 and D11. Double check that in the code that that's right, but you kind of see where I'm going. That all 4 of these servos need to be on independent data pins because they need to act independently. You could probably write the code a little bit better to make these, maybe these 2 can operate on the same data pin and these 2 can operate on the same pin. I just did it separate just because I wasn't sure at the time how I was going to wire everything and how the servos were going to move, so I just decided to wire the data pins independently in case I needed to do different degrees for them. Totally up to you what you want to do. The other callback is this is a reed switch. I use this for controlling the opening and closing. You can use like a button or a limit switch, doesn't really matter. Reed switch is normally open. Basically, if you put a magnet to it, it connects these 2 metal plates inside this glass tube, and it completes the circuit, which triggers the servos to open. So I have that on data pin 7. So whether you use a reed switch, limit switch, button, whatever, just put the data pin on data 7 if you're using my code, and then your ground on whichever ground you choose. You got 2 options here. And that's it. That's kind of the diagram for how I wired everything to the Arduino Nano. I'm powering it off this USB micro, I think it's a micro mini, I forget which one this is, but and it's powered off the power bank that I showed earlier in the video, and it works fine, no issues. Like I said, powering the servo separately and then powering this with the lights off of a power bank, perfectly fine. How about the code? I'm going to assume that you already have the Arduino IDE downloaded and know how to load a sketch. If not, there are plenty of tutorials out there to do that. I'm not going to go over that today. I will say that the 2 header files you need to run this code if you're going to use my code are servo.h and fastled neopixel.h. Now, if you're not doing the lights, you don't need this header file, but I highly recommend if you're doing the lights. It's an easy to use class that kind of defines colors and makes using the NeoPixel strips a little bit easier. There are other classes out there, other libraries that you can use. It's up to you. If you don't know how to get these libraries, all you need to do is go to Sketch, include library, manage libraries, and then once it loads, you'll be able to search based on the name. So you would just type up here fast LED or servo, and then it will populate, and then once it populates, you just click the install button and it installs it to your library. And once it's installed, then you shouldn't have any issues. Now, next thing we want to do, I'm going to define my data pin 6 and number of LEDs. Again, I didn't end up using 10 LEDs on the strip. I used 9. It's fine as you go over, it doesn't matter. And then the data pin is 6. Again, if you're not going to do the LEDs, you don't need to worry about doing this. It's only for the LEDs. Now, for the servos, and this is the big part, my data pin is 7. So if you remember from the diagram, whether you're using a read switch, button, whatever, this is where you're going to put your data on. If you don't use 7, use some other number, just make sure that the button pin is, or the data pin is this for the servos, to control the servos. Now, for the actual servo data pins, remember I have them in 9, 10, 11, 12. These are actually the data wires coming from the servos themselves, from the motors. These you want to define separately because we're going to change the degrees on those separately. And then you want to create 4 servo classes. I just named them servo and servo 2, 3, and 4. And then you have a variable defined as angle and initializing at 0 degrees. And then I have a last button state, current button state. These 2 variables are going to control whether or not you know if your button's been pressed or not. That's basically what these do. And then earlier I was talking, if you're not doing the lights, you don't need to worry about this class. But if you are, this is kind of defining the NeoPixel strip object. So you pass in the number of LEDs that you have on your strip, which are 10. You pass in the data pin, which we define as 6, or whatever you designate as your data pin for your lights. And then this is just the orientation of the NeoPixels, the RGBs on there. This is kind of the standard how they are. And then you just define the object as strip. So later you'll see where we use those. And then define a constant brightness, which is 255. The lowest you can go is 0, which means it's off. 255 means it's the brightest. And now you're going into your setup. So this whole area right here will run once when the Arduino is initialized, when you plug it into a power supply, unplug it, and plug it back in. Each time it's going to run the setup. This is just mainly for debugging purposes. If I had an Arduino connected, I could show you, but basically there's this thing called a serial monitor that if you have it running and you have it connected to your computer with the Arduino connected, you could write specific lines like this. Like if I was testing whether the button was working, every time I hit the button, I should see this line in the serial monitor print out, button is pressed, button is pressed. You don't need it, but if you want to debug, that's the way it is. For the button, we want to define the pin mode. So the pin mode tells us what state the button is in. So we're going to initialize it as input pull up, which means it's high. The next is strip. So these two things are for the LEDs. Again, if you're not doing them, you don't need to worry about it, but you need to put this in if you're using the fast LED NeoPixel class. You need to do strip.begin. This basically initializes the strip. If you don't have this, nothing will work for the strip. It won't do anything. The next thing I do is I set the brightness, and we already set the brightness to 255 here, so I'm setting it to all the way. So now we're just attaching those servo pins to the servo objects down here. So L1 is on the first one, L2 is on the second one, and so forth and so forth. And then we want to initialize a starting angle. So where do we want these servos to start at? So you can see I have several different angles or degrees of angle. Now, the reason I don't have these as variables is because it wasn't working. I don't know why it wasn't working, but it wasn't accepting anything past this variable. Otherwise, I would have all of these as different variables. That way I don't have a constant number in this. But I was in the con crunch, so I got this working and I left it. So if you can get it working with variables, great. If you want to use standard, constant numbers, that's fine too. But as you can see, I'm setting each servo at a different angle. And that's just basically how you have your servo set up inside your backplate. So however you have it installed and however you have the arm position, that's where you want your starting position to be. So you may need to play around with these numbers to get them accurate. They may not be the same as mine. And then we set our current button state to whatever the button pin is. So we're going to read the pin for the button, and we initialize it as high, so it should read current button state as high. And so that's all the setup. Now here's where everything runs constantly. So in your loop class or loop function, this is where it's just going to keep running and running and running. This void setup runs once, initialize, and then it's done. Your void loop function is constantly going. It's constantly moving. So every time you want to detect like a button press or some sort of change, this is where you're going to put this in. So as you can see, we have our last button state variable is equal to current button state. So basically we want to save the last state, whatever the last state of the current button state was, so that we can detect whether or not it's changed or not. And then we set current button to whatever we read as the button. So remember, we did this up here. So current button state should still read high. We haven't hit the button, we haven't touched or done anything at this point. Now, if we get down into this loop, if you see this if statement, so we're going to say if the last button state was high and the current button state is low. So what this means is we've looped through, nothing happened, hit the button. When you hit the button, that changes the current button state. So our last button state was high, and now you're saying when we digital read this, it's saying low. It's reading low. That means the button's been pressed. So we want to do something. What do we want to do? We want to open the back flaps. Now, here's where I just kind of check to make sure that the angles are set at the initialized value. And it's only checking the first one. You could do this different ways, but this is how I did it. So I'm going to check if the angle is equal to 0. If that's 0, then that means we're at the starting position and the flaps should be closed, so we want to open them. So now I'm going to say the angle is equal to 50, and then I'm going to say servo.right angle. So angle is equal to 50. Now I'm telling the servo go to 50 degrees, and I'm telling 2 to go to 60 degrees, I'm telling 3 to go to 0, and I'm telling 4 to go to 120. Now, this is telling the servos to actually move, and we want them to move out. We're going to increase the number. Now, I know this looks a little weird. That's because probably servo 3 is sitting in the back plate upside down. So if you kind of remember, I wanted the servos in a different position. You can't do negative numbers on a servo. So if you wanted to kind of reverse its direction, if it's sitting upside down or sideways in a separate direction than it normally would be sitting, you want to start it at a higher number and then go to a lower number, but that's still going to push out the flap. So you kind of need to play around with these numbers to kind of get which angles you need to put in here. And then I fade in the red light. So this is very brief, but it's kind of cool. If you're not doing the lights, you don't need to do it. I basically define color as red, so 255, so this is RGB. So I just want red, so 255. And then I have a for loop to set each individual pixel on the NeoPixel. So you have to set each one to the color that you want it to be. So I have a for loop, my number of pixels should be 10. It's going to read from the strip that we created up above, and then it's going to loop through and set all the colors to red. Now, as of this point, it hasn't done anything yet. It hasn't shown anything. To get it to actually show, you have to do this. You have to call this method show strip.show, and that'll turn the NeoPixels on. Now, what I did here, and it's totally up to you whether or not you want to do this or not. I wanted it to be like a fade in effect when it opens. So when it opens, it kind of has like a fade in red, and it gets brighter as it opens. It's very brief. It's not super intense, but I think it's kind of a cool effect. So basically, I'm looping through 255 times, which is the maximum amount of brightness it can go. So it's going from 0 to 250. And I'm just doing a small delay, because otherwise, if you didn't put this delay in, it would just immediately open and you wouldn't even notice it fading in. So basically what I do is I say for loop, and then I'm setting the brightness to X, which is going to increase each time it goes through. So it's going to start at 0, then 1, 2, 3, all the way up to 255. And I'm saying strip.show each time. So each time it's going through, the NeoPixel is getting brighter and brighter and brighter and brighter and brighter and brighter until it hits 255, and then it's done. And then once it's done, then I just have a 2-second delay. This 2-second delay is kind of something that I came up with a while back when messing around with faceplate motorization. I found that sometimes if I didn't put a delay in on the trigger or on the button, if I accidentally hit it and then hit it again real quick, it would open, close, or it would do it real quick when I didn't want it to. I'd be almost triggering it accidentally. So this 2-second delay actually just keeps it from you triggering it accidentally and it staying open. So if I want to hit the button and open the flaps, and then accidentally hit the button again before the 2 seconds is up, nothing's going to happen, because this delay is basically just telling the code that, hey, stop for 2 seconds, and then if you detect another button press, then do something. So this is just kind of just a way to keep it from accidentally going up and down real quick, because sometimes you can burn out servos doing that, or they can get out of place on accident. Totally up to you whether or not you want to keep this. You can increase it, decrease it, get rid of it. It's up to you. All right, so we've got our flaps open. So what happens when we press the button again? So this loop is still going. So when we press the button again, remember, now our current button state is low. So when we come in here and we say we want last button state equal to current button state. Current button state is low, so last button state is low. Now I want you to read the button again. Well, we pressed it. Okay, now it's reading high. So now our last button state was low and our current button state is high. So if we come in here and we say last button state is high, no, that doesn't work. So now we fall down here into the else. Now this, you could say else if last button state equals low and current button state equals high. I kind of find it redundant. You don't really need it. You're only going to have two states, high or low. It's up to you whether or not you want to do that. But basically, once you hit that button again, as the flaps are open, you want them to close. So here, checking the angle. Angle equals 50. That means the flaps are open. We told the servos to move to 50-degree angle. Now I want them to move back to their initial starting position, 0, on the servo 1. So now servo 1 is going to write angle, which is 0. Servo 2 is going to write the 120, which, again, remember when we initialized servo 2 was 120. Servo 3 is going to go to 50. 4 is going to go to 60. And I want to turn my lights off, if you had the lights. Basically, you define a color as 000. Remember RGB, so 000 means black. There is no such thing as black. That just means it's turning them off. But you still have to loop through and tell each color to turn off, basically. And then I just do a 10 millisecond delay. You don't really need it. And then I do my 2-second delay again. This is again just to keep me from accidentally triggering the flaps to open, close, like within milliseconds of each other. And that's it. That's all the code. So that's the coding side of coding the Arduino and wiring up circuitry for the servos. There's probably different ways you could do it. I'm sure there are other ways people have done it in the past, but that's how I did mine. Feel free to use my code. I'll list it below in a link. I hope you enjoyed the video. If you didn't go watch part one goes over all the hardware and all the parts you need to motorize this. Maybe I'll do something else in the future if you guys want to see some more tutorials from me. If not, appreciate the views. If you like the video, hit the like button. And until then, see you.